Hello, everyone. This is Keith Jackson, and welcome to Jack's Math Notebook. In this video, we're going to simplify non-perfect squares. And we have two big examples to show you how we can do that. And so let's take a look at the square root of 245. It may look a little daunting, but here's all we have to do to find out the factors of 245. We could just get the prime factors of that number until we arrive at a perfect square root. And so we know that 5 is a factor of 245 because 245 ends in a 5. And so we know that 245 divided by 5 would give us 49. I can go further, but guess what? 49 is a perfect square root. So we can rewrite it this way. The square root of 245 is equal to the square root of 5 times 49. And let's go ahead and rewrite it so we can see it a little more clearly that the square root of 49 is 7. We can park it right out front. And then we're just going to leave 5 inside the radical because it doesn't easily lend itself to being square rooted. And so our answer in this case is going to be 7 square root 5. And if you notice that right here, this 7 square root 5 is just simply the number that is on the side of a square because 7 times the square root of 5 times 7 times the square root of 5 will give us 245, y'all. Okay, and let's go ahead and move on to our second big example in which we have the square root of 360. And let's get the prime factors of 360 until we arrive at a perfect square root. And so we know that we can easily use 2 because 360 is an even number, and we know that 2 times 180 is, will be equal to 360, but we can further prime factorize 180 this way because we know that 2 times 90 will give us 180, and let's keep going until we find that perfect square root. And so the factors of 90 will be 2 times 45, and then we have 45, and the factors here are 40 of 45 will be 5 and 9. Oh, guess what? I have my perfect square root because see, I can write it right here. So now let's go ahead and put all these prime factors, except for 9. 9 is not a prime factor, by the way. But let's put that all into the radical. So we have the square root of 2 times 2 times 2 times 5 times 9. We already know that the square root of 9 will give us 3, so we can park that 3 right out front. And we're just going to keep that 5 inside the radical right here. And we know that 2 times 2 times 2 will give us 8, so we have the square root of 8. So again, so we have the square root of 9 times the square root of 5 times the square root of 8. We already know that the square root of 9 is 3, so let's put it right here. And we're going to leave 5 inside the radical, so we already have the first part taken care of. So we have 3 times the square root of 5. Now we know that 8 is the same as saying the square root of 4 times the square root of 2. Guess what? The square root of 4 is 2. So we're going to put that 4 right next to this 3 right here. So we got 2 times 3 times the square root of 5 times the square root of 2. And guess what? We know that the square root of 5 times the square root of 2 will just give us the square root of 10. And we know that 2 times 3 will give us 6. And so our answer is 6 square root 10, which is the number on the side of a square. And so that's our answer. All right. You have been given a lot of information. I wouldn't blame you if you need to pause this video to take a look at these two big examples or replay this video as many times you need to gain a deeper understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.